That's good.
So we looked at that. And then we looked at how do you find our target. Then the tool we use is Energy Star, and all you need to know is these two items, zip code and square footage.
Hey, Trevor, I have a question about the 20% cap. Isn't that being driven by the Corporation Commission basically because the utility companies don't want? I mean, they still want to be able to provide 80%.
Yeah.
So, and isn't that potentially subject to change? I mean, why do you think that would stay 20%
this 20%
for the next 10 years?
Well, this 20% is something that Architecture 2030 at MASTRIA has set a limit. Right. And I think their intention is if you leave that 20%, if you don't have such a cap, what most of us would do is not control our design and just design whatever we can and go off and purchase green power from SRP and APS to offset our problems,
Okay.
Yeah,
which is what they don't want to do.
Because
Yeah, I
power
was thinking
companies
of the
don't have a limit on the RECs they can sell because
Right.
we're going to want energy credits they sell, the better for them.
Yeah.
Because the
Right.
government's forcing them to buy and sell these things to advance the green energy research.
Sorry.
So we understood using Energy Star Target Finder, how do you find your building's target EUI? And then from there, this third week, we started dividing that EUI number and try to conquer each part. So just as an example, I'm going to walk you through how I came to these things using some of the programs today. But just as an example, in the Phoenix area, a school would be in the range of 50 to 70 EUI kilobitules per square feet per year. An office would be in 60 to 70, 80, and a prison probably be in upper hundreds. And we looked at how different sources, a different fuel source plays into that EUI number. All these different proportions of sources, where that energy is going. Is it going to lighting? Is it going to heating? We looked at all these different things. It is important to know this at a rough level beginning of the project, because then we can start to focus our efforts on the biggest piece of this pie and try to solve that first and then go to the next step. And then we looked at what does energy analysis entail. It has three parts. We have to put in a lot of information into the model and use one of the available tools, which is what we're going to look at today, and find the results. And we also looked at the difference between energy modeling and energy analysis, which is very critical when it comes to preparing our fee structure and offering our clients what we can do out of the basic services and what we cannot do. So we looked at what energy modeling is, what energy analysis is. This is something we can offer to some extent within our basic scope of services, but energy modeling would require a lot of time. So that's something that we looked at. So far good? So far good? Okay. Next bat.
Now we know why we don't have any pads.
So we looked at energy modeling, or energy analysis, and we looked at how it is very important to just change one of the ingredients to understand what is going on with the building. And then we looked at, okay, what do we do this process on every single job? How do we solve this problem from a practical standpoint, profit and loss standpoint? So we looked at business as usual. If we don't do anything, then we could get to, if we do an energy analysis at the end of our design, we could be, our range of hitting that target is really, really wide. And we could narrow that range by doing, by checking every design decision through the process. But that's going to consume a lot of our fees and time. So the compromise is to do this on key decisions that we want to ensure that we are going the right track, and to use that knowledge for future projects in the same type and same zip code. So then we come to our 2030 story, which we're trying to say that we should first ask the appropriate questions and then find the relative facts to that questions, and then use and provide reasons for our design decisions based on these facts, and then finally validate some of these key decisions with our analysis tools. And the following weeks we started looking at it from an envelope, lighting, and system standpoint. We haven't touched yet on renewables. So the processes, which is kind of what I'm going to go through today, during our visioning exercise that we have on every project, that's the time to do all the questions. And then right after that is the fact-finding session. That's where you prepare climate book. And this is something that we did for Tucson, a climate book. It's basically just a printout from climate analysis consultant software. This is something that we could do very easily for each climate, each location, and have that around in our office so that it's easy to understand what these things are during the design process. And then the next logical step is to figure out shape, form, and orientation. If we have 3 or 4 options, what are the energy part of those options also. And then finally, we can get into some heavy daylighting analysis and energy modeling. Okay. And then I think we started looking into we started looking at lighting. I'm just wondering, did I miss the entire envelope discussion? But anyways, we're jumping into lighting. So we looked at visual comfort as part of our 2030 story. Lighting is an important story we have to tell. In order to tell that story, it is important to understand what visual comfort means. So we looked at all of those things. So we start understanding the basics of lighting, the source, how do you treat the source, what are the different types of lighting sources, and what are the different types of surfaces that light gets reflected on or passed through, and how are some of these observer characteristics impact our lighting comfort. Look at all those things. Okay. And we looked at some standards like ASHRAE and IESNA, which govern some of these lighting comfort standards. And this was important. We looked at glare a lot because most of our lighting solutions fail because we don't pay enough attention to this item, glare. So it is important to understand direct glare and reflected glare, and we looked at options to solve those 2 problems. And we looked at a typical classroom. What is the recommended ratio in order to contain glare? We looked at different things between the whiteboard and the adjacent surface. You want to have a 1:10 ratio. We looked at all these different things. And why we always try to place the tables in an open office environment at this 30 to 60 degree comfort zone to avoid direct glare and indirect glare. Am I going too fast?
No,
I have to. Okay.
No.
Okay. So then we looked at another important topic called the PSALI technique, permanent supplementary artificial lighting interiors. This is something that we haven't been following, but I think it's very important that we start looking into it, because this changes how we start designing lighting systems. And the assumption behind this is you use artificial lighting only as a supplement to daylight. So our first and foremost goal is to figure out how to get daylight and how to figure out how far we need to get, and also reduce direct glare and indirect glare. So we didn't spend a lot of time on this, but I'm going to talk about a software that we can do this. And then amazes me somehow we missed I missed the building envelope. I don't know, maybe I forgot another tag. But we looked at the V in HVAC ventilation. When it comes to HVAC design, it is very important to understand interior air quality and how that impacts the energy consumption. So we looked at those things. We looked at various pollutants in the air and how do we solve these pollutants. And we looked at when it comes to heating and cooling, what are some of the governing comfort factors that drive heating and cooling? And we're mainly in here in the Phoenix Valley, we're mainly in the cooling mode, so it is important not only to understand air motion, relative humidity, but also air quality for the reasons mentioned. And then we talked about the different types of systems, heating, cooling and heating system, and decentralized versus centralized. And we went through all the different types of systems, from the very passive to the most active system, and kind of associated that with cost. And we also looked at simple criteria to select systems, find out the building operation first, and find out how we want to zone the building, and then decentralized or centralized, how do they want to maintain this building. And then this one is very interesting, uniformity versus diversity. Do you want uniform thermostat temperature in the entire building, or do you want to have few places in your building go up and down, or different climate factors? So that's all we looked at. Any major questions before I get into the tools? No? I'm good?
Good.